Hello everyone. Today we're going to be working on 11D, which is dividing with scientific notation. Our content objective is students will be able to perform operations expressed in scientific notation, specifically division today. Language objective is students will be able to explain the steps to divide numbers in scientific notation. And why am I learning this? Well, it's important for real-world problems like comparing distances between planets. So remember our essential questions the same as the previous lesson. We want to think about how we can use the properties of exponents to simplify expressions. So background knowledge, we went over how to use properties in a case like this when we're dividing bases that are the same. What we can do is go ahead and subtract the exponent. I do explain in a previous lesson that division is repeated subtraction, and that's the reason why we subtract the exponents here. So we're going to do 10 to the 3 minus 6, simply add the opposite, and you're going to get 10 to the negative third power. And because we're going to be working with scientific notation, it is okay for our exponents to be negative. Same thing here. We have an 8 and a negative 4. Since it is division, we're going to do subtraction, since division is repeated subtraction. So notice here I put 8 minus 8, negative 4. Please make sure you actually put a negative 4. Students often have the tendency to put 8 minus 4. So it's very important that you put minus a negative. So here you're going to get 8 to the 12th power, because if you add the opposite, you would essentially have 8 plus 4. Okay, the other background knowledge I want to go over is scientific notation. What are the requirements? Well, A here is what I refer to as your coefficient. A is very particular. It has to be between 1 and 10. It's allowed to be 1, so it can be equal to 1, but it can not be equal to 10. And B, which is your exponent, has to be an integer, so that means no decimals and no fractions for the exponents. It has to be nice whole numbers. And then, of course, we want to remind ourselves how we multiplied scientific notation, because it's very similar to what we're going to do with division, except instead of multiplying, we're going to divide. So with multiplication, what we first did was collect the coefficients. So here, 2 and 1/10, 1 and 5/10. And then we collected the base tens with the exponents. So then we just applied the property of multiplying exponents by first we multiply the coefficients, and then here we applied the properties of exponents, we added them together, and we got our final answer. We always check to see if our coefficient fell in within the correct range, and if it did, that was our final answer. And if it didn't, we would have to make some changes. For example, in a case like this, if we did the same exact steps, and we noticed that the coefficient was too large, we would have to adjust. So in a case like this, we would have to say, okay, we're making this smaller, so we're going to multiply by 10 to negative first, and we have to multiply this by 10 to the positive first to balance things out, because 10 to the negative first times 10 to the positive first is 10 to the 0, and anything to the 0 power is just 1. And multiplying anything by 1 doesn't change the value at all, so it's okay. So our final answer would have been 1.9142 times 10 to the 16th power. Okay, so now with that said, let's go ahead and start dividing. So dividing is very similar in the sense, first thing we're going to want to do is collect the coefficients. And since this is a fraction, fraction is essentially division, we're going to go ahead and put 9.1 divided by 3.5. And then we're going to go ahead and divide the base tens with the exponents. Notice since scientific notation is in that form, a times 10 to the b power, we're still multiplying, as you can see here. So here we're going to put 10 to the 12th over 10 to the 7th. Now all you're going to have to do is simplify this right here. 9.1 divided by 3.5. Just a quick reminder, you're going to have to make the divisor a whole number, so you're going to have to move this decimal one place over. You're going to do the same thing here, and then you would just go ahead and divide. 35 goes into 91 2 and 6/10 times. We're going to go ahead and now, since this is a fraction, we're going to subtract the exponent. So 2 minus 7 gives us 2.6 times 10 to the 5th power. Now we're going to check our coefficient. Does it fall in the range between 1 and 10? Absolutely. So this is going to be our final answer. So it's very similar to multiplying with scientific notation, except now instead of multiplying, we're going to be dividing this time. Okay. So now go ahead and try numbers 1 and 2 on your own and see how well you do. Okay, so for number 1, hopefully you gathered the coefficients together. 8.4 divided by 2.1, and then we're going to multiply, since that's the form scientific notation is, we're going to multiply by the base 10, so times 10 to the 19th over 10 to the 5th. We're going to go ahead and divide the coefficients, leaving us with 4, and then here, since it is a fraction, we're going to subtract the exponent, so 19 minus 5 gives us 4 times 10 to the 14th. 4 falls in within the correct range of 1 through 10, so I'm going to go ahead and say that this is our final answer. So hopefully you got that one right. Now let's take a look at number 2. Same idea. We're going to collect the coefficients first, and then we're going to multiply it by the collection of the base 10s with the exponents. Now here, dividing 5 and 5/10 by 1 and 2500ths, you're going to get 4.4. Now this is where you have to be careful again with your exponents. Please express the work here. We're going to do negative 3 minus 1. So here, if you add the opposite, you're going to get 4.4 times 10 to the negative 4th. And once again, exponents are allowed to be negative in scientific notation, so we're actually going to leave it like that. We don't want you to turn it into a positive exponent whatsoever. So hopefully you got those ones right. If not, feel free to pause the video and check the work again to see where you went wrong. Other than that, we're moving on to some more dividing with scientific notation. So with scientific notation, just like with multiplication, there might be a case where the coefficient isn't good. It may be too small or too big and you're going to have to adjust. So here's an example. We're going to follow the same steps, 4 and 3/10 divided by 5. And then we're going to go ahead and pair up the base 10s with the exponents. So we're going to multiply that by 10 to the 11th over 10 to the 23rd. Then we're going to divide 4 and 3/10 divided by 5 gives me 8600ths times, we're going to have to subtract these exponents, so 11 minus 23. Here I'm going to add the opposite, so that's going to leave me with 8600ths times 10 to the negative 12th power. Now before I circle my answer and say that I'm done, I'm going to check my coefficient. Does my coefficient fall within the range of between 1 and 10? No, because it's too small. It's actually less than 1. So I'm going to have to adjust it. In order to make this within the correct range, I'm going to have to move my decimal over once to the right, which would technically make this decimal larger. Since I only have to move it once, I'm going to go ahead and multiply it by 10 to the positive 1 this time. And to keep things balanced, I'm going to multiply this part by 10 to the negative 1st. Now, why am I not multiplying by the same thing? Because usually with that phrase, whatever you do to one side, you do to the other, you would need 2 sides. Unfortunately, if you see this equal sign, there is only 1 side. So we don't do that. Instead, we want to do you think of it as the inverse power, because if we do this, for example, 10 to the negative 1st times 10 to the positive 1st, this is going to give me 10 to the 0 power because these powers are inverses. Sorry, not 1. Not 1, let's make that a 0 to be correct. By having these additive inverses is going to create the power of 0, and anything to 0 power is 1. So multiplying by 1 doesn't affect the value of this expression at all, so that's why I'm able to do that. So from there, I can go ahead and say that my answer is 8.6 times 10 to the negative 12 minus 1. Now, why is it minus 1? Technically, it's plus a negative 1 because we are multiplying. So this is going to give us 8.6 times 10 to the negative 13th. That would be our final answer. Why? Because my coefficient does fall within the range of between 1 and 10. Okay, so I'm going to actually have you try the next 2 examples on your own. So go ahead and try it. Okay, so let's take a look at number 3. So after dividing 4 and 83 hundredths by 7, hopefully you got 69 hundredths times 10 to the 7 minus 3, which is going to give you 69 hundredths times 10 to the 4th power, because 7 minus 3 is 4. Now this coefficient is too small, so hopefully you adjusted it by multiplying by 10 to the 1st, which means you'd have to multiply this by 10 to the negative 1st. Remember, the exponents need to be additive inverses, because if they are, then it'd be 10 to the 0, and anything to the 0 power would just be 1. And it's okay to multiply expressions by 1 because it doesn't change the value at all. So by doing that, you are moving the decimal over 1 to the right, leaving me with 6.9 times 10 to the 4 plus negative 1, since it is multiplication, which would leave us with 6 and 9 tenths times 10 cubed. Number 4, same idea. We're going to go ahead and divide the coefficients, leaving me with 24 hundredths times 10 to the negative 8 minus negative 3. So it's very important you put that minus and that negative 3. Do not combine them together. So here, I'm just going to go ahead and add the opposite, which is going to leave me with 24 hundredths times 10 to the negative 5th. And again, before I go ahead and circle the answer, you want to make sure your coefficient falls within the range. This is actually too small, so I need to adjust it by multiplying it by 10 to the, well, let's see how many places we're going to have to move it. 1 to the right. Because we're moving it 1 to the right, we are making the value larger. So we're going to go ahead and say it to the 1st power. And to even things out, we're going to multiply this part by 10 to the negative 1st. So here, that's going to leave us with 2.4 times 10 to the negative 5th plus negative 1, which of course would leave us with 2.4 times 10 to the negative 6. Now I can circle my answer because my coefficient does fall within the correct range of between 1 and 10. Okay, so now there's yet another type of division with scientific notation. Now, we've worked with dividing before, and in most cases, division, actually in real life, most division problems aren't going to come out nicely. So in a case like this, I would set it up like I would in like the previous problems. I would go ahead and set it up as the coefficients divided by each other, and then the base 10s divided by each other. But you're going to notice in this one, 8.2 divided by 6.7 does not end nicely. It actually goes on forever. So what do you want to do there? Well, in a case like this, we're going to actually round to the nearest tenth, because I don't expect you to keep going on forever and ever. It's never going to stop. So because I'm going to ask you to round to the nearest tenth, now here's where you're going to have to be careful. If you notice that as you divide, your coefficient is good and it falls in within the range of 1 and 10, then all you really would need to do is at least get the hundredths digit, because that would be enough for you to round. I don't expect you to divide so many digits. You only divide as much as you need. Okay, so in a case like this, we're just going to go ahead and round to the nearest tenth, like I said before. So all you need is the hundredths digit, and that's going to leave you with 1.2 times 10 to the 6th power, because you add the opposite. 4 plus 2 is 6. So that would be the answer. Now there is another case, so it's going to come up in a couple examples, so stay with me. So let's take a look at number 5. Here we're going to do the same thing. We're going to go ahead and divide the coefficients and multiply that by dividing the tens as well. Here, once we divide 6.3 divided by 1.1, we actually get 5.727272. So here, now again, because it's going on forever, I would hate for you to keep dividing over and over. What I want you to recognize is, hey, this is 5 point something. That's definitely going to fall within the correct range that I want. So all I really need to do is go up to the hundredths place. So essentially, I would want you to stop right here, because you wouldn't need all these extra digits to round, because this 2 is what's going to tell me whether or not the 7 is going to go up or stay the same. Since 2 is less than 5, we're actually going to go ahead and keep it as approximately 5.7. 7 does not go up, times 10 to the 4 minus 8. Again, is because it's a fraction, we're going to subtract the exponents. Now notice I'm using the word approximately mainly because it isn't exact. It's a repeating decimal and we did have to round. So that's why we would use, it's like a squiggly equal sign. We would read that as approximately. So I'm going to say it's approximately 5.7 times 10 to the negative fourth. Because here, if you add the opposite, we would see we have more negatives than positives. Okay, now looking at number 6, we're going to go ahead and do division of the coefficients and division by the tens. Now here, notice this coefficient is actually less than 1. So because we know we're going to have to adjust the decimal place. So for example, I know my decimal is going to eventually move here. Notice I can't stop at the hundredths place, mainly because then I wouldn't know what the next digit is to tell me whether or not I should round up or stay the same. So here, I did go up to the tens, hundreds, thousandths place. Okay, so here I'm going to go ahead and adjust because this coefficient is too small. I'm going to multiply it by, whoops, got ahead of myself. Let's go ahead and simplify our exponents real quick. If we add the opposite, we're going to get 0.819 times 10 cubed. Now here, I can go ahead and adjust my coefficient. Because it's too small, I'm going to multiply it by 10 to the positive 1. So notice right here, there you go. I would have needed this 9 to determine whether or not this one is going to go up or stay the same. So that's why for this case, because my coefficient was too small, I did have to divide to the thousandths place. Now, if that makes no sense to you, the best rule of thumb when asked to round to the nearest hundredths, to play it safe, just always round to the nearest thousandths. Okay, so here I multiply by 10 to the first, so here I'm going to multiply by 10 to the negative first, which is going to leave me with 8.19 times 10 to the second power, because 3 plus a negative 1 is 2. Now, real quick, because I was asked to round to the nearest tenth, I'm going to go ahead and look at the 9 and determine whether or not the 1's going to stay or go up. Since 9 is greater than 5, we're going to go ahead and increase it to approximately 8.2 times 10 squared. So again, if you have no idea what I'm talking about when I'm referring to the coefficient, if it's too small and how many digits you're going to need, just play it safe and always at least divide to the nearest thousandths. Because if this decimal gets adjusted, then the digits that you're going to require is going to change. Okay. So now I want you to go ahead and pause the video, try number 7, 8, 9, and 10 on your own, and let's see how well you do. Okay, so let's take a look at number 7. Hopefully you set it up and you got 1.4 times 10 to the 5 minus 13, which leaves you with 1.4 times 10 to the negative 8. Number 8, after the division, hopefully you got 0.15 times 10 to the 0 minus a negative 3. So again, this is where students often mess up and they often put 0 minus 3. So please remember you have to put the minus negative. So here I'm just going to add the opposite, leaving me with 0.15 times 10 cubed. The coefficient is too small, so I'm going to have to adjust it by multiplying it by 10 to the positive 1 because I need to move it just once over. So this part I'm going to have to multiply by a negative 1 because once again, these exponents are additive inverses, which is going to create 10 to the 0 power. 10 to the 0 power is just 1. So multiplying by 1 doesn't change the expression at all. So my final answer is going to be 1.5 times 10 to the 3 plus negative 1, which leaves me with 1.5 times 10 squared. Okay, so the last two problems. Number 9, here after the division, I got 1.57. So notice it does go on forever, but because this coefficient is within the correct range, I only had to go up to the hundredths place. So from there, I'm just going to add the opposite here, and that's going to give me approximately, oops, almost forgot, I'm going to round. The 7 is going to cause the 5 to go up, so it's going to be approximately 1.6 times 10 to the negative second. Now number 10. Now here, notice this coefficient was too small. That means I would have needed an extra digit because I know my decimal is going to have to move over. So here, Let's simplify the exponent first. Add the opposite. You're going to get it raised to 10 to the fifth power. So here, again, because this is too small, you would have to adjust it by moving it once over to the right, making the number larger. So that's 10 to the positive 1. So now that's why you're going to have 2 digits afterwards to do the correct rounding, because I am asking you to round to the nearest 10. Here, since you multiply this part by 10 to the positive 1, you're going to have to multiply this part by 10 to the negative 1, which is going to leave you with 8.04 times 10 to the 5 plus negative 1. Now here, we're going to round, looking at the tenths place, okay? This 4 is going to cause the 0 to stay the same. It's not big enough to make it go up. So I'm going to get 8.0 times 10 to the 4th power. Now, real quick, just to prove a point, if you kept on always dividing to the nearest hundredth, if you left it as 0.80, once we move the decimal over, you'd have 8.0, and there would be no number to determine whether or not the 0 would stay or go up. So you just have to be very careful and think about it. But again, if you don't understand what I'm trying to say, it's best that you always round to the nearest thousandths. It's your safest bet. Okay, so that is actually going to conclude our lesson for today. Thank you so much for taking the time to watch the lesson. And like always, until next time, bye.